And I'm actually vlogging today, so yay for that. This week we had to choose between a chapter in the book or two articles that we read. So I'm going to talk about this article right here, which is backwards to you, but it's called Why and How to Differentiate Math Instruction, which is differentiation's really good, but it can be really difficult when you're just starting to think about it. So this was actually a really helpful article because it gave me some ideas about how to start differentiating math, which I, like most people, think of as kind of one way, even though there are multiple ways to get there. And I don't completely get how to make it more accessible. But I need to, and so this is very helpful for that. And on that note, let's get into the article. Okay, so before we get too far into this article, I want to read something that NCTM has to say, and that is, equity does not mean that every student should receive identical instruction. Instead, it demands that reasonable and appropriate accommodations be made as needed to promote access and attainment for all students. So not just the students that are struggling, not just the students that are doing really well, for all of them, even the middle ones, which can sometimes be forgotten. And so, two things that really stood out to me in the article was it talked about two modes to differentiate instruction. One of them was by using open questions. There's a bunch of different ways that you can frame open questions. But as an example, they gave us two questions, and one is open and one is closed. Well, not like closed, but more difficult to access. Question 1 is the one that's more difficult to access, and it is, to which fact family does the fact 3 times 4 equals 12 belong? And I don't even know what a fact family is, and this is supposed to be for elementary school kids, so I wouldn't be able to access that question. But I would be able to access the second question, which is describe the picture at the right by using a mathematical equation. And there's the picture. It's a 4 by 3 x's. And so students would be able to say that it's like 3 plus 3 plus 3 plus 3, or 4 plus 4 plus 4, or they can say that it's 3 times 4, but there's many ways that they can go about it and still be accessing math just on their level. And so, some strategies for creating these open questions. So the first strategy for open-ended questions is to turn a question around. And they give the example that what is half of 20 becomes 10 is a fraction of a number. What could the fraction and number be? So they could do it multiple ways. They don't have to do half. If they're excelling, they can do like a third, so it would be 30. And then they're also accessing the number, so they're creating their own number and their own fraction instead of being told that it has to be half. Another method is asking for similarities and differences. So how is this like this? How is it different than this? Replacing a number with a blank. Their example is, instead of asking how many students there are altogether, if there are 25 in one class and 31 in another, students could be asked instead, using this replacing a number with a blank, to choose two numbers for the two class sizes and determine the total number in both classes. So they can choose numbers that they're comfortable with. If they're only comfortable with doing single-digit numbers, they can say that there's 8 in one class and 6 in another class, and so there's 8, 9, 10, 11, 12, 15, 14 students altogether. Or if they're comfortable with working in the teens, they can do numbers in the teens, or if they're even beyond that and starting to work with the 20s, they can do it there. So it's really accessible. Another is creating a sentence. For example, a teacher could ask students to create a sentence that includes the number 3 and 4 along with the words and more. And here are some examples that students came up with. Was that 3 and 4 are more than 2, 4 is more than 3, and more than 1, and 3 and 4 together are more than 6. And then there was even another student who took it to the next level and made 3 and 4 34, and so they said 34 and 26 are more than 34 and 20. And so that's accessible in many different ways. They can use it as greater and less, they can start adding, they can do all these things, and it's accessible. Using soft words, it says to use use like close to 100 or close to this or close to that, instead of using the number is this, the answer is like add to 100, just add close to 100. I'm not sure how much I like that one, but I wouldn't have to use all the methods in this, just ones that I think would benefit my class. So that might not be one I use, but it might be one I use. And another one was change a question, which was pretty straightforward. You just take a question that you might already be provided through the textbook or worksheets or whatever your school uses, and you make it open-ended using those strategies. And the other strategy that they talked about in here were parallel tasks. So let's talk about parallel tasks. I had a nice little sheet I want to show you for parallel tasks. So this, it's probably backwards for you again, is the sheet in here that we were given for parallel tasks and open questions. Actually, it has both of them. And I'll explain that a little more later, but I just wanted to show that to you before I started. So parallel task is giving the students two options. One option is for students who are still working on building their mathematics, and the other is for one that know the mathematics that we're working on and to increase it, but they sound similar, so they're working on the same standards. For example, if you're working with length and perimeter and area and all those geometric fun terms, a choice could be an object has a length of 30 centimeters, what might it be? And then the other is an object has an area of 30 centimeters squared, what might that be? And so they're both working with the number 30, they're both working with measurement of an object, and the big thing about parallel questions is that the follow-up questions are accessible to everyone that's been working on it. So the follow-up questions in this case were, is your object really big or not so big? How do you know this? Can you hold it in your hand? How do you know that your object has a measure of about 30? So like it's talking about the tools they used. How would you measure it to see how close to 30 it might be? Also talking about the tools, which are going to be the same for both shapes. And how do you know that there are lots of possible objects? So those can be used as questions to both of those choices that were given, which I can use in my lesson plan. Not entirely sure how yet, but it's something I'm going to look at as I go forward in creating my lesson plan. And I'm also going to look at this lovely chart that I showed you when I'm working on my lesson plan some more, because it gives the goal of the assignment, of the task, and then the standard, the grade level, and the big underlying idea, which is something you want to get to because the standards are really lengthy and confusing. And then they show you write an open question for it, and you also write a parallel task, and then right down here I would write follow-up questions for my parallel tasks. I feel like the follow-up questions are really important and they get all students engaged. And so that's this week, and I'll put another vlog up next week. Whether that's Wednesday or Sunday, we'll yet to see. So have a nice week.